The A1013 transistor is a PNP bipolar junction transistor that is commonly used in switching and amplifier circuits. Before using it in any electronic project, it is always a good idea to check whether it is working properly. A simple digital meter is all you need to check the transistor is working correctly or not. The easiest way to test a 1013 transistor is by using the diode testing mode on your digital multimeter. This mode measures the voltage drop across the transistor internal PN junction and quickly tell you whether they are working correctly. If the transistor is still soldered onto the circuit board, try to remove it before testing. Other components connected to the transistor can interfere with the reading and may lead to incorrect results. Before you begin, identify the three transistor pins: the emitter, the collector, and the base. Knowing the correct pin configuration is important because connecting the probes to the wrong pin will produce misleading readings. Since the A1013 is a PNP transistor, the testing procedure is slightly different from the NPN transistor. The black probe is used on the base during the forward bias test instead of the red probe. Start by placing the black probe on the base pin, then touch the red probe to the emitter. A healthy transistor will usually display a forward voltage drop between about 0.55 volt and 0.75 volt. After checking the base to emitter junction, keep the black probe on the base and move the red probe to the collector. A good transistor should again show a voltage drop in the range of approximately 0.55 to 0.75 volt. These two readings confirm that both internal PN junction are conducting correctly in the forward direction. This is one of the first signs that the transistor is likely in good condition. Next, reverse the probe by placing the red probe on the base and the black probe on the emitter. In this direction, the transistor should block the current, so the multimeter should display OL, that means over the limit. Repeat the reverse test between the base and collector by keeping the red probe on the base and touching the black probe to the collector. A healthy transistor should again display OL in the multimeter. If both reverse bias tests show OL, it means the transistor junction are blocking current as expected. This indicates that they are not shorted internally. Now check the Now check between the collector and emitter without touching the base. In most cases, a good transistor should show over the limit in both probe direction because there is no conduction path when the base is left open. If the collector and emitter show a very low resistance or a buzzer sound, the transistor is probably shorted internally and should be replaced. Sometimes you may see a reading close 0.00 volt between two pins. This almost always indicates a short circuit inside the transistor and it is clear sign of the damaged transistor. If every measurement displays over limit regardless of probe placement, the transistor may have an open junction. This usually means the internal semiconductor junction has been damaged. Don't worry if your forward voltage reading are not exactly the same time. Small difference such as 0.58, 0.62 volt, 0.69 are perfectly normal. The exact voltage drop can vary slightly depending on the manufacturing production batch. and even the temperature of the transistor during testing. While testing, avoid touching both the multimeter probe with the finger at the same time. Your body resistance can sometimes affect sensitive measurements. It is also a good idea to make sure the multimeter battery is good condition. A weak battery can produce unstable or inaccurate readings. If you are unsure whether your readings are correct, compare with the new A1013 transistor. Comparing two devices often makes it much easier to identify a faulty one. Always double check the transistor pin out before testing. Accidentally mixing up the emitter and collector pin in one of the most common mistakes beginners make. Some digital meter include a dedicated transistor, a test socket, although I features is useful. The diode test mode is usually the preferred method because it gives more detailed information about the transistor junctions. If the transistor has been exposed to excessive heat or electrical overload, it may fail even if it looks perfectly normal from the outside. The electrical testing is the best way to confirm its condition. A transistor that passes the multimeter test is generally healthy, but it can still fail under high voltage or heavy current in an actual circuit. Functional testing is sometimes required for complete verification. If the transistor fails any of the junction test, replacing it is usually the safest option. Using a damaged transistor can cause the entire circuit to malfunction. When placing the A1013, always choose a compatible replacement with the similar voltage, current and power rating to ensure reliable current operation. And also store the spare transistor in a dry place and preferably inside an anti-static bag, and proper storage help to protect them from moisture and static electricity. Testing transistor regularly is a useful habit for anyone working with electronics. It can save time by helping you identify faulty components before assembling project. With a little practice, checking an A1013 transistor become a quick and stand-forward task. Most tests takes less than a minute once you familiar with the procedure. By following the simple multimeter checks, you can confidently determine whether your A1013 transistor is working correctly or not.